Hi kids, in this video we are going to solve sums from exercise 14C, Rectilinear Figures, class 9 from Concise Mathematics. We have already done till sum number 30. You can click on the I button and get the video. Look at sum number 14, very interesting. The following figure shows a trapezium ABCD in which AB is parallel to DC. We know in a trapezium, one pair of opposite sides are parallel and the other pair is non-parallel. And AD is equal to BC. They have given this. Prove that DAB is equal to CBA. I'm taking the first part one by one. Look, what I'll do to prove the first part, I'll drop perpendiculars on AB. Okay, so DM and CN, suppose. So I'll draw a perpendicular, So DM and CN are perpendiculars on AB by construction. Now look at triangle AMD. Triangle I'm talking about AMD and triangle BNC. BNC. We'll prove that they are congruent. Our work will be done. Very easy. AD is equal to BC, that was given to us, isn't it? Angle DMA is equal to CNB. By construction you can say that, isn't it? Now look carefully. If you look at MNCD, this angle and this angle are 90. These two are parallel, which means this angle and this angle will also be 90. So if in a quadrilateral, you see, one pair of sides are parallel and all the angles are 90 degree, it means that MNCD is a rectangle. And if it's a rectangle, the opposite sides are equal, which means DM, we can say, is equal to CN, opposite side of rectangle, isn't it? Done. So we can say that by these three, that triangle AMD is congruent to triangle BNC. It will be RHS, right angle, hypotenuse and side. RHS, because if this is a triangle, this is 90 degree, then AD becomes a hypotenuse. And if these two triangles are congruent, we can say that this angle and this angle are equal, which implies angle DAM is equal to CBN CPCT. And if you look carefully, DAM is nothing but DAB, which implies DAB is equal to CBN is nothing but CBA. Okay, first part is done. Now look at the second part. They prove that ADC, which means this angle, and BCD, which means this angle, are equal. Very easy. AB is parallel to CD, which means simply angle DAB plus ADC will be 180, co-interior, they are supplementary. We know if two lines are parallel, then this and this angle act to give 180. They are co-interior, which means suppose I take this as X, okay, so DAB is X plus angle ADC is equal to 180, which means angle ADC is equal to 180 minus X degree. Similarly, if you see angle ABC plus BCD is equal to 180, co-interior, angle ABC plus BCD equals to 180, that's co-interior, they are supplementary, isn't it? If two lines are parallel, again two lines are parallel, suppose this is parallel to this is a transversal, then this angle and this angle add to give 180, supplementary. Angle ABC we have marked as X because these two angles are equal, we have already proved over here. So X plus BCD is equal to 180, which means angle BCD equals to 180 minus X. So from, suppose this is 1 and this is 2, from 1 and 2, from 1 and 2, we can say that angle ADC is equal to BCD. Proved. Done. Pretty easy. Now look, the next part. AC equals to BD. Very easy. Take this triangle ADB. Look at this. I'm taking triangle ADB and triangle ABC. ABC. First of all, AD is equal to BC. That is given to us. AB is equal to AB. That's common. And angle DAB is equal to CBA. We have already proved in the first part, which means those two triangles are congruent. If they are congruent, of course, AC and BD will be equal. Look, in triangle ABD and triangle BAC, AB equals to AB, that's common, isn't it? AD equals to BC, that is given to us, and angle DAB is equal to CBA, already proved, which means combining these three we can say that triangle ABD is congruent to triangle, now A corresponds to BAC, that's side angle side. So if they are congruent, we can simply say that AC is equal to BD, that's CPCT. Done. Pretty easy. Now look at the fourth part. OA is equal to OB and OC equals to OD. We know if we can prove that AOD and OBC are congruent, our work will be done. Now look carefully. Okay, just now we proved that these two triangles are congruent. So this angle and this angle will be equal. Angle, this we'll use it in the last part. Look how angle BDA is equal to angle ACB, okay, CPCT, which means BDA, which means this angle if you look carefully, and ACB means this angle if you look, are equal. Now our work is very simple. Look at these two triangles. This and this angle are equal, vertically opposite angle. These two angles already proved they are equal, and AD equals to BC given, which means these two triangles are congruent, angle side, isn't it? Look at what I'm saying. Triangle AOD and BOC, triangle BOC. First of all, AD equals to BC, that is given to us. Then angle AOD is equal to BOC, that's vertically opposite angle, isn't it? And angle ADO is equal to BCO, angle BCO. Why? Because see, we have already proved that angle BDA is equal to ACB, already proved, which means triangle AOD is congruent to triangle BOC, and if they are congruent, this is angle side, if they are congruent, definitely AO is equal to OB and OD is equal to OC, isn't it? Which implies OA equals to OB and OC equals to OD, CPCT for both of them. Okay, this was not tough. You need to choose the triangle properly and proceed. For the first part, I just dropped two perpendiculars DM and CL. Rest of the part was very easy, okay? Now let us look at the next sum. Now look at sum number 15. Very interesting. In the figure, AP is the bisector of angle A and CQ is the bisector of angle C of a parallelogram ABCD. Prove that APCQ is a parallelogram. Now look, first of all, angle A and angle C will be equal, isn't it? Because in a parallelogram the opposite angles are equal. Angle A is equal to angle C. Just look carefully. And AP is the bisector of angle A, which means if this angle, I'm talking about DAP, angle DAP will be equal to PAB, will be equal to PAB, isn't it? Suppose I take this as X, so this will be X, no doubt in that. Similarly, CQ bisects angle C. So this angle and this angle has to be equal. And since angle A is equal to angle C, so we can say if this is X, this is X, isn't it? We can say angle BCQ, BCQ is equal to QCD, QCD is equal to X. Just look carefully, okay? Now what I'll do, I need to prove that APCQ is a parallelogram. See, I'll join AC. AC is the diagonal of ABCD and BD is another diagonal. The diagonal intersect each other at O, and in a parallelogram the diagonal bisect each other, which means we can say AO is equal to OC, no doubt. DO is equal to OB, no doubt in that. Now just look. If we can show that in this quadrilateral APCQ, the diagonal bisect each other at O, then our work is done. Because in a quadrilateral, if the diagonal bisect each other, then the quadrilateral is a parallelogram. Now look carefully. AO equals to OC is already given to us. Our main motto is to prove that PO and QO will be same. Look at these two triangles. Okay. Now, I'm talking about triangle APO, APO and triangle CQO, CQO. My main motive is to prove that these two triangles are congruent. So this and this side will be equal. Our work will be done. Now look carefully. Look at this angle. CAB. I'm talking about angle CAB. And look at ACD. ACD. They will be equal. Alternate angle, isn't it? Which means suppose this is Y. So this is Y. Suppose I take as Y. Then, if you look carefully, you know, this angle, the entire angle was X, this portion was Y. So this angle will be X minus Y. Similarly over here, this entire angle was X, this is Y. So this will be X minus Y, isn't it? Now look at these two figures. Angle POA, angle POA is equal to QOC, that's vertically opposite angle. So this angle and this angle are equal. AO is equal to CO, you know, because in the parallelogram the diagonal bisect each other, already said. Okay, now look carefully. Angle PAO, angle PAO is equal to angle, if you look, QCO, QCO, that's X minus Y. Look carefully. Okay, angle PAO actually was PAB minus OAB. So I took PAB as X and OAB I took as Y. Similarly over here, isn't it? This is equal to this, which means these two triangles are congruent. Angle, side angle, because this side and this side equal. Very easy. Triangle APO is congruent to triangle CQO. Angle, side angle. And if these two triangles are congruent, we can say OP is equal to OQ. Now in quadrilateral, APCQ, diagonal bisect each other. How? Because AO is equal to OC and OP equals to OQ, which simply means APCQ is a parallelogram. Remember, in a quadrilateral, if the diagonal bisect each other, then it's a parallelogram. Okay, draw the diagram properly, mark the angle and do it. Easy. Now let us look at the next sum. Now look at 16 part 1. In case of a parallelogram, prove that the bisector of any two adjacent angles intersect at 90 degree. Very easy. Just draw the diagram first. Suppose A, B, C, D is a parallelogram. Suppose AO is the bisector of angle A and the bisector of angle B is OB. They meet at O, definitely. We need to prove that this angle required to prove is what? Angle AOB is 90 degree. Very simple. Now AO bisects angle A. So if this is X, this is X. OB bisects angle B. So if this is Y, this is Y. Isn't it? Now angle A plus angle B is equal to 180. They are supplementary, co-interior. In a parallelogram, the adjacent angles are supplementary to each other. Now angle A I can write twice X, angle B I can write twice Y equals to 180, which means X plus Y equals to 90 I can write. Now look at triangle AOB. In triangle AOB, angle AOB plus X plus Y equals to 180. That's angle sum property, isn't it? Now X plus Y is 90, so angle AOB equals to 180. 180 minus 90, because X plus Y was 90, so angle AOB equals to 90. Proof. Which means the bisector of any two adjacent angle meet at 90 degree. Done. Okay. Look at the second part. The bisector of opposite angle of a parallelogram, of course, are parallel to each other, which means just draw the diagram. Look over here. If this is your parallelogram, suppose A, B, C, D, the bisector of opposite angles are parallel, which means suppose AM is the bisector of angle A. AM bisects angle A, and suppose not drawn properly, suppose CN bisects angle C. We need to prove that this AM and CN are parallel to each other. Pretty easy. AM bisects angle A, which means, can I say this is X and this is X? AM bisects angle A, which means angle DAM is equal to MAB is equal to X. Am I clear or not? Now, in a parallelogram, the opposite angles are equal. So angle A equals to angle C, which is equal to 2x, because this is X and X. So that will be also X and X, isn't it? Because CN bisects angle C. So we can say NCB, angle NCB is equal to NCD. NCD is equal to X. Am I clear or not? Now look carefully. Angle, just look carefully. Angle NCD is equal to CNB. CNB is equal to X, alternate angle. Which means what I'm saying, this angle and this angle are equal, isn't it? Now look these two lines. Look at AM and NC. MAB, angle MAB is equal to CNB is equal to X degree. And when will this happen? when these two are parallel, because these two becomes a corresponding angle, which simply implies AM is parallel to NC by corresponding angle property. Remember, if these two are parallel, then this angle and this angle are equal, corresponding, which means the converse. If these two angles are equal, then these two will be parallel. We have used that property over here. If you can draw the diagram clearly, the sum will be done. Okay, now let us look at the next sum. Now look at this sum, number 17. Very easy. The diagonal of a rectangle intersect each other at 90 degrees. Prove that the rectangle is a square. Now we know that square is a type of rectangle in which the adjacent sides are equal. So in this case, if we can prove that the adjacent side of this particular rectangle are equal, our work is done. Now, what is given to us? They have given that in this rectangle, suppose A, B, C, D. Of course, this and this sides are equal and this side is equal. The diagonal intersect each other at 90 degrees. Okay. Now, one thing we know that in a rectangle, the diagonal bisect each other, which means AO will be equal to OC and OD will be equal to OB. Diagonal bisect each other. We know this. Bisect each other. See, we need to prove that ABCD is a square. If you can show that AD and CD are equal, our work is done. The adjacent sides are equal. Then the rectangle transforms into a square. Just prove that these two triangles are congruent. Our work will be done. Just look over here. In triangle AOD and triangle COD, AO is equal to OC, isn't it? Angle AOD is equal to COD, that's 90, it was given to us. OD is equal to OD, that's common, which means triangle AOD is congruent to triangle COD by side property. Look, it was very easy, isn't it? Now, if they are congruent, we can say that AD is equal to CD, AD is equal to CD, CPCT, which means the adjacent sides are equal, which means the rectangle becomes a square, which means ABCD is a square. Why? Because in a rectangle, again I'm saying, if the adjacent sides are equal, it becomes a square. Very easy. Now let us look at the next sum. Now look at number 18. Pretty easy. In the figure ABCD and PQRS are two parallelograms such that angle D is equal to 120. This is 120. And angle Q is 70. Angle Q is 70. Find the value of X. Pretty easy. PQRS is a parallelogram. PQRS is a parallelogram, which means angle S equals to angle Q equals to 70. Opposite angle of a parallelogram are equal, which means if this is 70, this will be 70. No doubt in that, which implies angle CSP. Angle CSP is equal to 70 degree. Done. Okay. Let this be O. Okay. Now look at ABCD. In ABCD is a parallelogram. Over there, if you look, angle D plus angle C will be 180. Angle D plus angle C will be equal to 180 because supplementary co-interior angle. In a parallelogram, the adjacent angles add to give 180, which means angle D is 120, so 120 plus angle C is 180, which means angle C is 60. So this is 60, isn't it? Now look at OCS, triangle OCS. X plus 70 plus 60 will be equal to 180. Angle sum property, which means X equals to how much? 50 degree. Done. Pretty simple. Just use the property of parallelogram and this sum will be done. Okay. Now let us look at the next sum. Now look at this sum. Sum number 19. Very interesting. In the following figure, ABCD is a rhombus. D is a rhombus. DCFE is a square. Angle ABC they have marked 56 degree. Find DAE. DAE, which means this angle. Find FEA. FEA. This angle. FEA. Let me see. Yeah. EAC. EAC. This angle. Okay. And let us see. AEC. AEC. We'll do that at the last, okay? Because we have to join EC. Look over here first of all. It's a rhombus. Okay? Which means angle B is equal to angle D, which is equal to 56. Just look carefully. So this is your 56 degree. Okay? I'm talking about in the rhombus, you know. This angle is 90, isn't it? Because EDC is a square. So we can say angle EDC is equal to 90 degree square. So what is EDA? Angle EDA is nothing but 90 plus 56. That's 146 degree. Now look at triangle EDA. EDA. ED is equal to AD. How come? Because ED and DC are same. It's a square, EDCF. And in the rhombus also the adjacent sides are equal, which means AD is equal to DC. See, ED equals to CD and AD equals to CD, which means ED is equal to AD, which means this triangle is an isosceles triangle, which means this angle and this angle will be equal, isn't it? So if this is X, this is X. Which implies angle DEA is equal to angle DAE is equal to X. So X plus 146 equals to 180. So 2X equals to 180 minus 146 is how much? That's 34. So X equals to 17 degree, which means DA is 17 degree. Done the first part. Then FEA. Very easy. FED is 90 degree. Now FED I can write FEA plus AED, that is equal to 90 degree. FEA we don't know, and AED we just got. AED is how much? 17. So 17 equals to 90 degree. So FEA equals to 90 minus 17 is 73 degree. Done. This is 73 degree. So till now we got, see, we got this as 17, this as 73, isn't it? Now that was EAC. EAC. Look carefully. Very easy. In the rhombus, the diagonal bisects the angle, which means AC bisects angle A. Okay? Now look carefully. Look at CBA. Triangle CBA. In that triangle, AB is equal to ABC. AB is equal to BC, which means this angle and this angle will be equal, isn't it? Suppose this is Y and this is Y. So Y plus 56 equals to 180. It becomes a isosceles triangle, isn't it? Angle sum property. We need to write, okay? Now over here also we need to write angle sum property. So 2Y equals to how much? 124, isn't it? Yeah. So Y equals to 62. So this is 62 and this is 62, isn't it? Now look carefully. Angle DAC is equal to ACB, alternate angle ACB. So angle DAC again we can split into DAE plus EAC. Just look carefully. And ACB B, we just got 62. And DAE, we already got DAE. That is how much? 17. So 17 plus EAC is equal to 62. So EAC is equal to 62 minus 17, isn't it? That's 45 degree, isn't it? EAC is 45 degree. Let us see. Yeah. Now the last part, they're asking angle AEC. So we'll join AEC. We'll join EC. Now EC, just look over here. EC bisects angle E. Now angle E is 90, which means this angle and this angle will be 45 degree each, which means angle CED will be 45 degree. Now CED I can write AED plus AEC. Look carefully. AEC, that's 45 degree. They told us to find AEC. So AED we already know 17. So 17 plus angle AEC equals to 45, which means angle AEC is 45 minus 17, isn't it? That's 28 degree, isn't it? Yeah. So that's 28 degree. See, the diagram looks complicated, but the sum is very easy if you approach in the right manner. So this was the last sum. Keep it till here. In the next video, we'll look at some other chapter. Till then, take care.